this?
No.
Okay, so it sounds like most of you guys and girls got the answer. They swim in the kiddie pool, is that what it was? Alright. Was there any of those from the worksheet that you'd like to see? I know you told me the answer. 14, here we go. Alright,
Number 8.
let me do 14 first, please. Okay. A triangle has a base of 14 centimeters. Okay, so let's just kind of draw this out. 14 centimeters. We'd have a height here. I don't know what that is yet. And the height of 3x minus 4. So the height is 3x minus 4. So base times height, you remember a triangle have to be 90-degree angles from each other. The area of the triangle is greater than 56 centimeters. So the area is greater than 56 centimeters. Okay? Solve the inequality. 1/2 times 14 times 3x minus 4 is greater than 56. Okay, where did the 1/2 just come from? Because it's a triangle, so in order to find the area of a triangle, it's 1/2 base times height, right? So the 1/2 is a constant that will always occur in this equation. So I think we could solve this. Let's see. I'm just going to multiply here, and that's just going to give me 7. I'm just going to do this a little bit at a time. Is that okay?
Yeah.
So it's greater than 56. I could distribute the 7 over both. So that's going to give me 21x minus 28 is greater than 56. I'm going to then add 28 to both sides. Help me out on this. If I add 28 to 56, what do I get? How much? It's 94?
Wait.
84? Waiting. 56 plus 28? 84? 28 plus 56? All right, and then I'll divide by 21. And what does that come out to? Oh, wait, it's greater than 4.
4.
Okay. All right, so hang on. So the 4, to find possible values of x. Okay, so they told us the area is bigger than 56 centimeters. It should be 56 centimeters squared. I don't know why the worksheet didn't have it. Maybe it was, they got lazy or something. So our x value needs to be bigger than 4. So what types of things would change on this problem? Will this change at all knowing x is greater than 4? Will the 14 change at all being that x has to be greater than 4? Why not? There's not an x associated. So that 14 is constant, stays there. Okay? The height's going to be changing, and this is going to reflect how the height's going to change. So this, yes, indeed, is the answer. Yes, we could write this as this. I mean, can we have an infinite height?
No.
The reality is no, but I mean, mathematically, yes. But, you know, it's not really going to happen. But, so, I mean, things that you could say if they asked you, if they went a little deeper on this, said, hey, what would the height have to be greater than? Then you could plug this in, and you could say, well, that's 12 minus 4. So the height has to be more than 8 tall for this whole scenario to work as well. So there's just different things for that. Was that one of the answers that was given? X is greater than 4. So it looks like the answers were only written in that notation. They weren't written in interval notation, which it's okay. Perfect. Ram, you had one that you wanted to see?
Yeah, number 8.
8. All right, number 8. We have 16 minus 4x is greater than 9 minus 5x. Okay? So we have to choose what we want to start with on this problem. I might choose to add 5x to both sides. You might have chosen something slightly different. Our answers should match up. Subtract 16. So I get x is greater than negative 7. Yeah, baby. Okay.
You do, can you do number 7?
Do number 7? trouble or anything. There's probably a note underneath the full part. Number 7, you said? 7?
Yeah,
7, okay. Number 7. 3 is greater than or equal to negative 3, x minus 13. Okay. I think we can distribute over parentheses here and here. So I have 3 is greater than or equal to negative 3x plus 39. Hey, why is it plus 39? I multiply a negative. A negative times a negative is a positive. Okay. So I'm going to subtract 39 from both sides. Those cancel. That's negative 36 is greater than or equal to negative 3x. Divide both sides by negative 3. So I'm going to get 12. Sign flips, doesn't it?
Yes.
Okay. But the x is over here now. So what can I do to this to get the x on the other side? Just take the whole problem and flip it over. So did it flip back to this because I multiplied or divided by negative? No. I just took the whole problem and flipped it over. Yeah.
Number 6.
6.
I got something wrong and I need to figure this out.
All right, we'll get there. Number 6. Looks like I can clear the denominator, right? So if I clear the denominator, what does it appear I should multiply everything by? 5? Okay. All right, so I'll multiply this by 5, this by 5 over 1.
I subtracted 6 first.
That should have worked. Did you get negative 8 on the other side?
I got x is greater than or equal to 40.
Okay, hang on. Hang on. So we get this.
I got.
What'd you get? I got that. I thought you said you got a 40 in your
I got
answer.
X is greater than or equal to 40.
Oh, you know what you forgot?
You forgot to switch to signs.
Notice how that negative? You forgot that negative. So at that point, you multiply both sides by negative 1, and that's going to flip-flop that sign. And there's your answer. Any other questions from the homework? Did we do 13? I don't know.
Okay, I got a question, sir.
Yeah.
Number 10,
10.
10 and 12.
Let me do 13 first,
Josh.
please. The students in charge of the class booth. Oh, it's a story problem. I can't wait to hear it for you. At the class booth at a carnival would like to earn $3 for every item they sell. They spend $55 for the materials to make the items. Solve the inequality 3x minus 55. 3x minus 55 is greater than or equal to 65. Which they want to sell items. They need to make a profit of at least $65. What's the negative 55 in this problem? Where did it come from? Yeah. Yeah, they were spending money to set up make their props, whatever, in order to sell. They want to make more than $65. What does the 3x represent in this problem?
$3 for every item.
So you buy an item, you multiply, it's $3, right?
See, stop giving me that look.
Rom, it is homecoming time. She might be thinking she wants to go to the dance with you. So. She said, yeah. I just heard it.
I might as well not. I might as well not.
All right. Sorry, I love you. All right. Shh. Agree? Esty, quit picking on boys. Do we agree with this? Agree? Gentry. Hi. Do we agree?
She's trying to get everybody.
No. I'm just trying to bring you back down. So, what does the 40 represent in this problem? What does the 40 mean in the context of this problem?
It's less than or equal to
$40 per item they sell.
Nope.
How much?
Nope.
There's nothing with 40 in the problem.
Nope.
But there's nothing.
Huh? Yeah. They have to sell at least 40 items in order to make that $65 profit.
Oh, nice.
Okay, that's what this means in the context of the problem. So the 3x represents they're selling every item for $3. The minus 55 was the money they're out because they had to purchase some things, perhaps the items, and then they wanted to make at least $65, so we set up this inequality. So the profit we're trying to make is $65. So once they start their sales, if they sell 40 items, starting at 40 items, that will get them at least $65 profit, meaning it makes back their money that they spent as well as gets them profit. That's an okay business plan. What's that? Do the next homework? All right, let's pass you on forward, please.
Wait, I have a question.
No, you don't. Pass these forward. Make sure your names are on this. I know Gentry's name's on his.
Yeah, my name is on mine.
Yeah.
What's your name? I know.
Hold on, then. Hold on.
Dinner. Let's do some notes, please. Well, SD, I'm sorry you feel that way. Not my intent. All right. Compound inequality. What do you notice about the inequality problem on the first page? Two inequality signs, right? So let's talk about this. So what I want to do is I want us to be able to solve these. And I want us to look at it on a graph, and then I want us to make sure that we can put it into interval notation. Is that okay? Okay. So, does everybody realize we have two inequality signs? And some things about these inequality signs you might notice. One of them has the equal sign, so that probably would mean there's a square bracket as part of the answer. And this doesn't have an equal sign, so it probably has a rounded bracket as part of the answers. Would that be an okay thing to say?
Yeah.
Okay. So, this is how we're going to work this problem. First thing is we have to realize it's two problems. And the middle goes with both problems. You'll see. You'll see.
Oh, I know.
Hang on. Shh. Being rude. Okay, so there's two problems up here. The middle goes with both problems. Okay, what if I say the term the middle goes with both problems? What do you think the middle is up here?
X minus 7.
Yes. Good. X minus 7 is the middle. Everyone agree?
Yeah.
That terminology makes sense?
Yeah.
So the middle goes with both problems. So both problems will have what?
X minus 7.
X minus 7 is a part of it. Good. So here is our first problem.
Oh, I get it.
Our other problem is this.
Oh.
I got you.
Is that right?
Yeah. You get it now.
So the middle goes with both problems. Everybody with me how this works?
Yes, sir.
So then let's do each problem individually. Okay, so I'm going to add 7 to both sides.
That's 11.
Okay, and then this one I add 7.
22.
Okay, so let's think about what. So if I were to take this, I'm going to circle that for a moment. I'm going to circle this because we're eventually going to get back to putting those back together. But I'm going to hold off for a second. So if I flip this over like that, do you feel comfortable with that?
Yeah.
Which means if I had this on a number line, if I had 0, I had 11, solid dot or open dot? Solid, going right or left?
Right.
Okay? What does, I don't have to flip this one over, it's already set up correctly. I'm going to put this on a number line, I have 0 and I have like 22, where 11 is here, right?
Yeah.
What is this, open or closed dot?
Open.
Open, going which way? Left.
Oh, then you meet.
Okay, hang on. Shh. Okay, so let's pause for a sec. I want to make sure we backfill any spots. Okay, so we have two problems that are, one problem makes two problems. The middle goes with both problems. Is everybody with me up to that point?
Yes, sir.
So we're good here, and we're good here. Okay, is everybody okay with how this becomes two problems here and here?
Yes, sir.
Anybody stuck there?
No, sir.
I am.
Okay. So there's disconnect. That's okay. Let's figure it out. So you're okay with the two problems, yes? And you're okay that the middle, x minus 7, goes with both problems. Okay, so all I'm going to do is this. There's my first problem. There's my second problem right there.
It's like absolute.
So it's like boom, that came right there. Boom, this came right there.
So, what do you do with the two answers? They all
Okay, you're going to see. We're not even there yet. Are you okay with the work so far? So I've created two problems. If there's two problems, I created two number lines. Make sense? Okay. Hang on. Let's see. So, being this started out to look like this. You guys ready for this? I'm going to now put these back together as I had circled them. Hang on. I'm going to put them back together how I circled them. Ready?
Yeah.
Notice, I have an 11, I have a 22. What do these both share?
X.
X. So if I put these back together, I get 11 is less than or equal to x, which is less than 22. So all I did is I just put these back together. To see how this was started? I put it back together to look like that. Why?
Yeah, I'm confused.
Okay, look. I have an x. I have an x. With me? Is it the same x?
Yes.
Yes. Okay? I'm going to meld these back together. These, we already took these apart. Now I found what x, the inequality is. Now I blend it back together. So these x's go back together. Notice this is pointing that way. Notice this is in the middle, and that's pointing this way. All I did is I took 11 less than, x, less than 22, less than 22.
Wait, but then wouldn't it be two?
Hang on. No. Was it 2x here?
No, but there's two.
No. Was it 2x here?
No, but there's two.
No. Was it 2x here? Listen what I'm saying.
X is on the
Listen what I'm saying. Stephen, out in the hall. I have a single x here. Agree. This is the exact same x here and here. Agree? So this x here and this x here are the exact same x. I don't have 2x. I just want to put these back together. So I took apart this, saying, okay, I want this over here, and I want this over here. I took it apart. Now I'm just trying to put it back together. So notice I didn't go and I circled this part right here because I wanted it to stay like that. So notice, see how this sign looks like this? See, everything about this problem right here leads to this scenario. Okay, I went to this part just so I could show the graph, but I kept this circle for a reason. So now I'm going to be able to put these back together. Okay, Esty? Yay?
I got it.
You sure? Abby?
Could you combine the 22 and the 11?
No. Because there's two problems. Here's our first problem. Here's our second problem.
But then, like, you just
But we have two problems. If I can't take two problems and go back to just one problem.
how are you able to select the X? What did that put together? Like, how did that help you in the equation? Because then are you just gonna add like 11 or 12?
So watch. So I think by getting to this last part right here, it's going to answer things. So now what I want is I want to create this and this together. So if I started at 11, solid dot, and I shaded to the right, and I with square bracket, and I started at 22, but now I'm going to go left with an open dot. So the number line now is going to look like this. 0, still with me? 11, still with me? 22, still with me? I'm going to put an open dot at 22. I'm going to put a solid dot at 11. Stop in there. Stop in there for a moment. Does everyone feel okay with that?
Yes.
So the 11 is shading to the right. The 22 is shading to the left. So now we have start and end points because I'm just shading between the two. Okay?
Oh, so that doesn't go into infinity?
Starts and stops.
Oh, I got
So, ready?
What's
Let-
interval notation?
Interval notation, ready? Square bracket at 11.
Oh.
Rounded bracket.
At 22.
Wait,
That's it?
wait, why would
Oh, okay.
wait.
Yeah.
For the equation, couldn't you just add 7 to both sides and then keep the x in the middle?
I see where you're going, and yes, you're absolutely right, and your brain sees it that way, and I love it. Not everyone's going to see it exactly that way, but you're seeing it that way, and I love it. Just be careful on that. So what you keep in mind is if you're going to do it your way, absolutely. Add 7, call it good. Okay? Totally makes sense. At this point, this might become a little bit more complex that it might not jump around as easy. Yeah, Jen.
So I went from 11 and stopped at 22.
That's it. Yeah. Anybody else? Steven, you ready to come back to school? He's crying. All right. Hey, he was taken away from your guys' education, so I had to get him out. He can watch the video and see him get scolded on there.
Oh.
Hey, I'm not gonna edit stuff out. That's no fun.
Yeah,
It's no fun. You know, I hate when you ever get those movies that have the extended features put on DVD. You're like, dude, this would have been so much better in the theater seeing it. Drives me nuts. All right, can I go to the next problem?
Yeah.
Okay. Look, does this look okay?
Yeah.
That look okay. Cool. What do you notice about the next problem?
It's much longer than the other.
It's much longer, and there's a word in there.
Oh, so I think I know what to do.
Oh, jeez. Here we go.
I think I got it.
Okay. So now here's a quick question, because can everybody see up here that this is 2 questions right now?
Yeah.
Yes.
Anybody going, dude? Or is a problem? No. There's 2 problems up here. Great. Yeah. You're gonna get there. Watch. All right. Ready? I'm just gonna solve each. So I have. Feel okay with that?
Yeah.
Feel okay? So this on a graph would be looking like this, I believe. 0 and I have 3. Open dot going this way.
Infinity.
Agree? Everyone feel okay with that?
Yeah.
And this one is 0, -8. Open or close dot?
Close.
Closed, shading left or right?
Left.
Left. Okay. So take a look at our 2 graphs, how we have them represented. Okay. If I went back to this board, I'll come back to this. Notice this one. They overlap definitely because, 11 was here, right? Will these overlap?
Yes.
Well, you did
No, they won't.
They're not the same
Oh
problems.
my
You
word.
can't put them together.
Everyone agree?
Three's over here.
So-
Three's
so,
over here.
If I put this onto a number line, I have 0 here, I have 3 here, I have -8 down here. Agree?
Yeah.
Does that make sense? And let's pretend I could draw it perfectly symmetric. Okay? So this says I have an open dot going this way. And this says I have a closed dot going this way. Yay?
Nay. Yay.
So will they overlap?
Why can't-
No. Hang on. Why what?
Why are you allowed to put them on the same number line if they're not the same problem? Because you can't do that.
They're the same problem. We're just combining them.
I like what you're saying. For right now, or problems. So, ready? Ready? We're going to make a big jump. I wasn't going to do this quite yet, but for you, I'm going to get there.
Uh-oh.
And comes together as one problem. Or goes opposite as one problem. And comes together or goes opposite.
Wait, so there's
Yay?
an and. So if there's an or in the middle, they go opposite.
So the and will already be put together. We're not going to have the word and.
Wait.
Or we have to put the word or because we couldn't figure out how to put them together in the first place.
But you.
Uh-uh.
What if there's like.
Uh-uh. All right. So our thing, I know I'm going to have -8 here. Where was it coming from? Negative infinity, rounded bracket.
I thought you combined the problem.
I did.
No,
I
you
did.
No, you didn't.
Or
No.
rounded bracket at 3 or closed bracket.
Oh, I see.
Rounded bracket at 3 or closed bracket.
Why would you do that? I don't understand. If they're not the same problem, why do you get them together?
They are the same problem. Okay? This is where you would see this type of problem. Okay? I'm going to get to it in a sec. So this is how the problem's represented. Notice what followed all the way through the problem. What two-letter word came to the end? Or. Okay? Or problems you do not put back together. They stay apart. Okay? So this is what it looks like when we do that. So this is where it will come into play. XY axis with me so far? Parabola with me so far?
Oh, yeah.
I'm gone.
We want the region this way, which is above the x-axis. The region this way, which is above the x-axis. The region in between is below the
No, but
x-axis. But this is so next semester. But that's what that kind of problem is. This is an or problem.
This is a U.
Isn't this a skewed graph?
No.
This is.
Yeah, it's a U problem.
This problem. All right. So
I don't know that.
backside of our page. Backside of our page. Okay, so somewhere close to the center, put a 0. You guys all with me?
For all three of the graphs.
Nope, just for the first one. Put a 0 somewhere close to the middle.
Number 9.
Okay? I'm just creating a problem.
Wait, is it close? What?
Okay? So draw that as your first item. Draw that as your first item. Okay, so with the knowledge I've instituted with you all so far, do you feel this would be an and problem or an or problem?
And.
Why do you know it as an and? It comes together.
They overlap.
Comes together. What do we know about the endpoints of this problem?
They're equal.
You're right, they are equal. It's not an open dot. So how do I represent a closed dot with interval notation?
Square bracket.
Square bracket. So ready? Ready? Square bracket, -5, comma, square bracket. Where did this one get to? Done.
Oh, that's easy.
It's not when it's a whole problem. Wait, so what if it's like both open?
Oh,
Could they go?
well, why don't we do that on the next one?
Wait, but like, could the open dots like go like through?
No, the difference.
So let's say this was an open dot and this was an open dot.
Yeah.
The only difference on the problem is this: parenthesis, no square brackets. That's the difference. That's it. Okay? Can I move on?
No, I don't get it. Why'd you put it in parentheses?
I was just showing if we had -5 and 7 as open dots, then I would use the red parentheses and not the blue squares.
I thought
That's
I
the
was-
only reason I did it. But for you, Rom, I'll take them away.
Thank you.
Oh my gosh. That's like no one.
All right. Next line. Still with me?
Yes. Wait, no zero. Wait, where's this? What? I'm so drawing. Now. Oh my gosh, I did that.
Why are you confused on that?
Because you moved the zero.
Think of a number line. Is 0 to the left of 5?
Yes.
Yeah, but why'd you have to move it?
Because 5 is on the right. You won't have space.
I don't get it.
That's all.
All right. What are my endpoints? What? 5 and 12. Is this an and problem or an or problem? It's and. Agree?
Square bracket.
So a square bracket at 5, rounded bracket at 12. Done.
Wouldn't it be 0 and 12 because the 0 at the end? No.
Where am I shading? Where am I shading? Okay, between 5 and 12, is there a 0?
Well, no, but it's there. It's at the end point.
Well, because you were panicked when I didn't put a 0 up there. So I put a 0 up there to let you know that it was to the left of 5. And it's also to the left of 12.
Oh my god. But it's actually. I don't know.
Do you need me to? Here, for you, I'll extend this number line for you. There you go. It's a different color, but deal with it.
Erase that didn't help. That made it worse because now it looks like there's a zero.
All he did was move.
I'm confused. Because
He
now it's
moved
like.
the scope of the
Ignore
screen.
the 0 for this one.
Oh my
Yes,
god.
dear, are you okay with this?
I don't know the number line.
What did we get up to 12?
I know the number line. The things you have to do.
Okay, you still with me on this? Now, ready? Negative one's over here.
Oh.
What?
Why don't you know that? I do, but
I forget what the problem was. Was it solid die or open die?
solid.
Okay.
Open on 12. Yeah, but that's not the endpoint. The endpoint is -1. No, the endpoint is not.
Where's my green shaded line?
5. 12.
There you go. Is 0 part of the shaded region? Okay. Woo! I'm glad I didn't pick 48 and 90. I'm still counting up there. Man, I'm getting tired. All right.
I can't just put the 0 in.
You can if you'd like.
Okay.
All right. Here, I'll do just for you.
What's that 0 on the farthest right?
-6. +6. Darn it. Oh, 0's back. Oh, so that's an or problem?
Why is it an or problem?
They're going opposite.
They're going opposite. They're not overlapping. Am I including my endpoints?
No, they're infinite.
No, I am not including my endpoints. All right, so where's this one coming from? Where's this coming from?
Negative infinity.
And where's it getting up to?
Positive infinity.
-6. Closed,
Rounded bracket.
rounded. Okay? What kind of problem was this?
Or.
Good. And then where am I starting up again?
Rounded bracket 3.
Infinity.
Infinity. And beyond.
Or. I don't like or
Yes.
problems. I don't like any
It's like
problem. You're a problem.
Yeah, right? Having to count off every single number.
What the heck? There's a problem.
All right. I think you have enough knowledge. Let's see, this is worksheet 4A. Worksheet 4A, which is page 55, 56. Let me take a look at page 56 though real quick.
Let's not do this because it looks sketchy.
It looks
Tomorrow.
Let's do this. Let's have you just work on the even problems on the entire worksheet. We will start class tomorrow by doing the odds. Good?
Good.
Yay.
Odds.
Perfect?
We love odds.
We love odds. That's true.
Isn't it movie nice cream day tomorrow?
I don't know.
Yes, it is because tomorrow's a Thursday and we have a short week. So